Okay, sorry about that last video. I am learning just like you are, so have patience with me. Okay, starting off back with number 7 on the notes from January 10th, talking about the discriminant. Alright, so we left off right here. B squared minus 4AC. Our B in this one is 22, so I went ahead and filled that in. Our A is 1, our C is 121. So from here, 22 squared is going to be 484. Okay, so then we have minus 4 times 121. And if you type it in your calculator, 4 times 121 is 484. So our discriminant is going to be 484 minus 484. We know that's going to give us 0. Alright, so we have a table over here that says if your discriminant equals 0, you'll have one real rational root. So for part B, to describe our number and type of roots, we'll have one real rational root. Now let's find out what that rational root is. So for part C, using the quadratic formula, we'll have negative b, so negative 22, plus or minus square root of 0 over 2 times a. In this case, a is 1, so 2 times 1 is 2. The reason we only have one real rational root when the discriminant is 0 is because the square root of 0 is 0, right? And negative 22 plus or minus 0 over 2, that's just going to be the same number. It doesn't matter if you add 0 or subtract 0. You're still going to get negative 11 for both answers. That's why we only have one real rational root. Okay, moving on to number 8. Our formula is in standard form, so we can go ahead and get started. Our A is 7, B is negative 11, C is 5. Part A, we're finding B squared minus 4AC, our discriminant. And again, for these videos, if I talk too fast, because I tend to do that, y'all can just pause them. It's a good thing about these videos. And you can rewind them or slow it down at your own pace. Alright, so B squared is going to be 121. Remember, if you're typing in negative 11 squared into your calculator, to put parentheses. Minus 4 times 7 times our C, which is 5. Alright, so right here we get 121 minus, and this is 28 times 5. Alright, so if we type that in to our calculator, we'll get negative 19 for our discriminant. And if our discriminant is negative, I'm going to come back up here, then we're going to have two complex roots, meaning that there will be an I somewhere. So describing our roots, there'll be two complex. Now let's use the quadratic formula. So we'll have negative b, so a negative 11 makes a positive 11, plus or minus square root of negative 19, all over 2 times a, so that's 2 times 7, that's going to be 14. Alright, here's where the simplifying radicals comes in handy that we just did. So we're going to have to simplify this negative 19. Are there any perfect squares that can go into negative 19? No, but we have to get rid of that negative. We can't have the negative out in the radical. So all we can do right here is do 11 plus or minus. We can take out the negative 1 because we know the square root of negative 1 is I. So our final answer will be 11 plus or minus square root of negative 1 is I. We have to leave the 19 underneath the radical over 14. So we have the two complex roots because we have a plus and a minus. The complex is because of the imaginary number, the I. Alright, last one. Before we do anything in this one, we have to put it in standard form, meaning that everything has to go on the left and it has to be set equal to 0. So we're going to start by subtracting 3 from both sides. Now that it's in standard form, identify our A, B, and C. That's going to be 2, 3, and negative 3. Now let's fill it into our discriminant formula. So B squared is going to be 9. minus 4 times 2, because the a is 2, times c, which is negative 3. Alright, so right here we have negative 4 times 2, that's negative 8, times negative 3, that's a positive 24. So that's going to make 33. Alright, 33 is positive, but it is not a perfect square. So if your discriminant is positive but not a perfect square, you're going to have two real irrational roots. Two real irrational roots. And what that means is, for your answer, you're going to have some type of radical for your answer. Excuse me. So let's go ahead and do quadratic formula. So we'll have negative b, that's negative 3, plus or minus square root of 33, all over 2 times a, which would be 4. Alright, can we simplify the square root of 33? Meaning, are there any perfect squares that can go into 33? And that answer would be no. So we can just leave our answer like this. So x would equal negative 3 plus or minus square root of 33 all over 4.